Alrighty, so what do we do in 2-3? 2-1 was about reminding us of little vocabulary pieces. As I said in the video, 2-1 is not going to be on this sheet because it's stuff we need to know. We have to remember that domain is the x's and range is the y's and all of those little things about whether or not it's a function or not. But it's not on here because that's really an 8th grade state standard. So when we get to 2-3, now we actually have a, hey, this is a junior state standard. I can find the slope of a line algebraically, graphically, and in the context of a word problem. Now my hope is that I'll get you all of the lesson today. That way you won't have to watch a video tomorrow. You'll just be working on the day 2 assignment as you go through here. Let's take a peek. Let's see what we remember from 2-1. And this might not, this is a review, so this might not be in your packet there for 2-3. First question is this a function? We know that the definition is, for every input, there's exactly one output. Does that one meet that definition? If you put in a 1, what do you get? -7. That's one number. It's okay. Put in a 3, you get 9. That's just one number. Put in a 4, you get a -2. Just one number. Put in a 1, you get, uh-oh. Didn't we say back here that if you put in a 1, you get -7? This is saying you also get a 5. This is not a function. For one input, there are 2 outputs. It's not a function. Now for the domain, what we have to do is use number set notation. And it's just kind of a funky bracket. Your brackets don't need to be perfect. Mine aren't going to be. I always write them way too fast. And I call that the Richard Nixon bracket because he was a former president who had a really big chin. And so he looked like that if he turned sideways. He looked like this bracket. And then I want to write the numbers down, and it's helpful to write them in order. Domain is the x's. So which values up there were x's? Come on, these are the easy ones. What are the x's? Okay, I guess I can't have volunteer today, huh? Nobody wants to speak? Ashley, give me some x's. Yeah, and because we already listed the 1, we're not going to list it twice. We're just going to say it's 1, 3, and 4. Those are the x's. The range is going to be the other ones, the y's. So, Landon, what were the y's? Yeah, and usually I'll try to put them in order according to the number line. You wouldn't have to. We'll take it either way. But the domain is x, and the range is y. That's a big part of section 2-1. The huge part from section 2-1 was, hey, is this a function? And you have to be able to tell that both by looking at ordered pairs and by looking at graphs. So in 2-3, we're going to start talking a little more in depth about those points, and you're going to find out that a lot of this is review. So linear functions in slope-intercept form, we have to be able to graph linear equations, which means graph lines. We've done that before. And write equations of lines. So, and again, it says working in small groups, but we're going to talk about this together. Define slope. Words, pictures, formula. What do you remember about slope? Anything that you remember from what you've learned in the past. Y equals mx plus b. That's usually the first thing that pops into everybody's head. That's called slope-intercept form. We use that a lot. So of that formula, which one of those stands for the slope? Riley, which of those letters stood for slope in that formula, if you remember? Yeah, because we can't use s as a variable. So for some reason, somebody decided m was it. So m is the slope. Now, most often, the first thing you hear about slope is rise over run. That's usually the first thing that people hear about slope. And then a little bit later on, you learn you can label your points. Oops, that's not going to look like an X. And then there's a little song to help you remember the formula. Slope, slope, find the slope, average rate of change. Y2 minus Y1 over X2 minus X1. Now, the reason that I have that little song is because when you get to the MCAs and the ACTs, they never say, find the slope. They say, find the average rate of change. So we have to know that average rate of change is the same thing as slope. So it's slope, slope, find the slope, average rate of change. Y2 minus Y1 over X2 minus X1. And hopefully that'll kick it into gear. Now, as you get to higher level math, we write this as delta Y over delta X. Delta stands for change. So change in Y over change in X. But right now, we're probably going to think of it this way. Y2 minus Y1 over X2 minus X1. We need to find that slope. Yeah. Yes, in the chapter 2 note packet. Ooh, let me grab it and see what page we're talking about here. It's in the green one, the neon green. Page 12. Yep, Taz up at the top going crazy. Page 12. All right, so now, in words, rise over run. Pictures we'll do in a second here. Formulas, yeah. Y2 minus Y1 over X2 minus X1. Absolutely. So now, down here, it says, now let's start thinking about those pictures, of what these lines would look like. I want to give everybody a chance to get that down. Although I do put this on Schoology in the completed notes as well. So if you feel like you're missing something, you can always get it from there. Anybody need more time to write down the definition up there? Well, let's see. I'm going to need some Cartesian coordinate planes. And if you have a different color today, make your Cartesian coordinate planes in one color and then grab a different color and we'll put our lines on in those different colors. Some are already drawn the lines. That's cool because you're feeling confident. So a positive slope. We read graphs just like we read words in a book, and that's from left to right. So a positive slope, it doesn't have to go through 0, 0. It just has to go up from left to right. So if that's a positive slope, what do you suppose a negative slope is going to do? Yeah, down from left to right. Zero slope. So it would have to have a 0 on the top. That would mean it doesn't have any rise. What kind of a line doesn't ever rise? Horizontal line. That has a 0 slope. Undefined slope, that would mean that we're trying to divide something by 0. That would mean it doesn't have any run. So it's a line that never goes left or right. What kind of line doesn't do that? A vertical line. Yeah. So for zero slope, we're talking about a horizontal line. And for undefined, a vertical line. Things we knew, and we just needed to pull them out of our long-term memory. Been a while since we did any graphing. Boy, yeah, because you guys had geometry last year, and they probably didn't get to, at the end of the year, we usually try to, encourage the graphing of lines again right before you come to Algebra 2, but last spring was pretty doggone weird. Calculate the slope of the line that passes through the given points. Oh, I know this one. Slope, slope, find the slope, average rate of change. y2 minus y1 over x2 minus x1. So that's what we're going to use to find m, our little slope. So for the first one up here, I would label this x sub 1 and y sub 1, and then x sub 2, y sub 2. Just put my little subscript of 1 on the first point and subscript of 2 on the second one. And m would equal negative 5 minus 2 over 4 minus a negative 10. Now here's where slope gets tricky. Look at all those minuses up there. And the most common mistake made in math is negatives. So you just have to be careful. Negative 5 minus 2 more would be negative 7. 4 minus a negative 10 would be 4 plus 10, which is 14. Now, obviously you could do that math on your calculator if you needed to in 2 steps. You could do negative 5 minus 2, enter, 4 minus a negative 10. But here's what you have to be careful of. Whenever you're using a negative number, make sure you put it in parentheses. Otherwise, sometimes your calculator will goof up because it doesn't know what you want it to do with what. Now, last but not least, in Algebra 2, we simplify everything. So negative 7/14 would be negative 1/2. I go to B, because I know that one's simplified. It's all good. And again, I'm thinking x sub 1, y sub 1, x sub 2, y sub 2, and eventually I won't need to write all those down every time. But this one is going to be negative 1 minus a negative 1 over 5 minus 6. Now, something probably felt a little wrong as you do. Negative 1 minus a negative, isn't that going to be 0? It is. Now, a 0 on the top is okay. That's just 0. That's what that is. A 0 on the bottom is bad. In fact, your calculator will yell at you if you try to divide by 0. Can't divide by 0. It just yells. But we said this was going to be special then. Slope of 0. Take a peek back at what we did when we did our drawings. What kind of line was it again that had a slope of 0? Yeah, this one. Horizontal. So, because it's special, I'm going to write that up here. This would be a horizontal line. Makes sense. Go 6, negative 1, 5, negative 1. Yeah, connect those two up. That's going to be a horizontal line. Looking at C. M equals x sub 1, y sub 1, x sub 2, y sub 2. Slope, slope, find the slope. Average rate of change. y2 minus y1 over x2 minus x1. Negative 3 minus 5 over negative 2 minus a negative 2. Again, you get that feeling something hinky's going on here. Negative 8 divided by 0. I want to show you how my calculator yells at me. So I get to this point and I'm like, so does that have a slope of 0 or is that undefined? Negative 8 divided by 0. Oh! Yelled at me! Can't do this. This is the undefined one. So what kind of line had a slope that was undefined? A vertical line. Yeah, this one's special too. a vertical line. Again, if we graphed it, we would see that. You know, it would make perfect sense. So for 4a, it says define linear function. Let's think root word. What's the root word of linear? Line. So if we graph them, what are we going to see? A line. So these graph as a line. Now what are we going to see in an equation that's going to tell us that it's going to graph as a line? The highest power of the x will be a 1. We won't see any x squareds, x to the thirds, x to the fourths. Those will not graph as a line. Lines have to be x to the first. That's called a degree 1 polynomial. Those will give us lines. Now it says, how can it be represented? Well, one of the first things that was remembered when we started talking about lines was this one, y equals mx plus b. That's the slope-intercept form. That's one way to represent a line. What is a solution to a linear equation? Well, that's what we're graphing. All the points on the line are solutions. They're x's and y's together that make the equation work, that make it true. So if we put them in, they better work. Otherwise, we're going to know, oops, our points are messed up, because they've got to work in the equation. They absolutely have to. Now, we really like a process called quick graphing. There's two ways that we have to do really quick line graphs. One is y equals mx plus b, slope-intercept. And the other one is by using what's called standard form. And standard form deals with these two things. So we're going to sketch a graph of a linear function, a line, and we're going to label the x-intercept and the y-intercept. So again, it would be good if you do your Cartesian coordinate plane in one color. And then make your line in another color. Now this time, don't let it go through 0, 0. Anywhere else, just not 0, 0. Because we want to have a clear picture of where the x-intercept and the y-intercept are. At this time of year, if you say the word intercept, what's your first thought of? Yeah, interceptions, right? That's what an intercept is. Because an interception is when a football player steps in front of somebody else and he catches a pass that was supposed to go to the guy behind him. Here, it's that interception taking place because it's crossing the axis. So this one crosses the x-axis. It is called the x-intercept. So when you cross that x-axis, what you're really doing is you're cutting off x and you're taking the pass from it. That's what you're doing. And then this one is doing the same thing, but to the y-axis. So it's the y-intercept. Crossing in front of it, stealing that pass that was intended for the y-axis. Now, you learned in geometry through the point line plane postulate that any 2 points determine a line. So if we can find these 2 points, oh, that would be super great, because then, boom, line, we've got it, we've drawn it, you know. So that'll be another quick graph way that we can get these done. Oh, sorry, I didn't ask and then I moved it off. Does anybody need more time for the x-intercept and the y-intercept? Okay. What is slope-intercept form? Oh, well, here we go again. Mentioned it before. And what does each variable stand for? Okay, let's see. You guys told me That's the slope, and you were right. It's called slope-intercept. So which of those letters up there stands for an intercept? B. B is, in fact, the y-intercept. Now here comes something much tougher. They said we have to tell them what all of the variables stand for. What do the x and the y stand for? The x and the y stand for all the points on the line. These are, together, ordered points, ordered pairs on the line. So M is the slope, B is our starting place. In fact, you start thinking, slope starts with S. They should have used an S. B, it's the y-intercept. Why isn't it a y? Because y is already in use up there. So they tried to pick this in a way that would make us think alphabetically, start with B first, then use M. So that's kind of helpful. Number 7 says, what is an equation of each line? Now, the only way I can use slope-intercept form is if they just hand me the slope and the intercept. Oh, look, that's what they did. Here's the slope. It's 6. Here's the y-intercept. It's at 0, 5. Y equals 6x plus 5. There it is. I just had to put the M where it needed to go, and the B, the y-intercept, where it needed to go. Now, B is a little harder. Here's why. They gave us points, and they gave us a line, but that means we have to figure out what the slope and the y-intercept is. And this, I know, is really super light, because it's hard for me to see it, and I'm standing right up here. So let me make that darker. But my first thought is, I'm supposed to start with B anyway. So I'm going to start back there. B is where it crosses the y-axis. Do we know where this one crosses the y-axis? Yeah, there's a dot right there. 1, 2, it's at -3. So that's going to be -3, because the point, 0, -3, was the y-intercept. Now the slope part. Well, slope is rise over run. So what we have to do is figure out, to go from one point to another point on this graph, left to right, how do you get there? And you could use either these 2 points, the higher ones, or you could use the bottom 2 points, or the top and the bottom. It makes no difference. In fact, let me do it this way. I'll go from the intercepts. And I realized I would have to go down 1, 2, 3. So my rise is a -3. And over 1, 2, 3, 4, 5, 6. Oh, well, I can simplify that. That's -1/2. Which is exactly the same thing I would have gotten if I had tried this little rise over run right here. So -1/2 x minus 3. Again, the only time we should be writing equations with slope-intercept form is when they hand us, hey, here's the slope, here's the y-intercept. Then we can do those. Now, 8 says, show how you can rewrite each of the following in slope-intercept form, then identify the slope and the y-intercept. Oh, well, how on earth are we going to make that look like that? Algebra! That's how we're going to do that. So here's the deal. I have to think just like I did back with literal equations when we did those. I have to find my y, because I want y to be all by itself, and it's right here. So that means my focus is on the left-hand side of this equation, and I want to get y all by itself. So I think order of operations backwards. Anything that's being added or subtracted over there, I have to move over first. They're adding 3x right now. I'm going to have to subtract 3x from both sides. One more step, and it'll be y equals mx plus b. What do I do to get y alone? Divide everything by 2. Now, negative 3/2, perfectly fine. It's simplified. There's nothing I can do with that. But 18 divided by 2, yeah, that's 9. So I want to make sure that I have that as 9. Now, we have it in slope-intercept form, and it said now we have to stop and tell them what is the slope and what is the y-intercept. Which of those two numbers is the slope? M. So which one is M? Negative 3/2. Well, what does that leave for the y-intercept? 9. It has to be. So we're going to put 0, 9, because the y-intercept, remember, is on the y-axis. 0, 9 will take us to that spot. Oh boy, B looks tough. It's got fractions. Love working with fractions. Raise your hand if you're with me. Fractions, yay, forever. Fractions? No? No? Okay, I'll have it your way. Then let's get rid of them. Here's how you get rid of them. You find the least common denominator, and you multiply every single term by the least common denominator, and then you won't have to work with fractions throughout the problem. Probably have some at the end, but not as you're doing your work. So we have a 4, a 2, and a 1. What's the least common denominator for a 4, a 2, and a 1? 4. So we're going to multiply all 3 of these by 4. Remember, you can do that. That's the multiplication property of equality. So here, the 4's are going to cancel right out, and we're going to get negative 3x. Here, the 4 and the 2 can do a little reducing, and we'll get negative 2y. And on the left-hand side, negative 1 times 4 is negative 4. Now it looks exactly like A. Remember, that's huge in math. If you can take something and make it look like something you already know how to do, you've done most of the work. All right, so I want y by itself. What should we do? Hopefully you're already doing it. You're trying not to make eye contact so that I won't call on you. Kayla, what could we do to get y by itself? Perfect. And I want to keep that x term in front because I want it to say y equals mx plus b. Jackson, what should we do after we've moved that 3x over? Yes, sirree, Bob, that's what we do. Divide everything by negative 2. So it'll be negative 3/2 x, and then be careful because negative 4 divided by negative 2 is going to be a positive 2. Not done yet, though, because they said once you have that, give us the slope and the y-intercept. So of those two numbers, Brandon, which one of those is the slope up there? And the y-intercept? No, yeah. Sweet. So if we can move everything else over, and it's y equals mx plus b, slope and y-intercept. There they are. A thing of beauty. Well, look at this. It says we have to do the same thing. Oh, and then we're also going to graph. Fun with graphing, which means I'm going to darken these because that is too light. Standing right up here, there's light shining in my face about 8 different ways, and it makes lots of shadows. There we go. Every year I reset them. Every year when I come back in the fall, the computer has set them back so that you can't hardly see them. Just happens. Original settings, I guess. Rewrite each in slope-intercept form. Oh, well, I should be able to call on anybody to help me with these then. So for 9a, we have 3x minus 4y equals 24. Marcos, step 1 for a. Yeah. Negative 4y equals negative 3x plus 24. Haley, after that? Be very careful. Dividing by a negative, we don't want to make mistakes with those negatives. So we'll have a positive 3/4 x minus 6. So now we need to know what is m and what is b, because we are supposed to graph this little puppy. Everybody already today? I have not. Josh, what is m? Y equals mx plus b. The 3/4. So b is negative 6, which means we have to graph 0, negative 6. All right, well, that's where we start, because remember, we do this alphabetically. We do the b first. 1, 2, 3, 4, 5, 6. Right down there. Oh, now I have to remember what 3/4 stands for again. Rise over run. Okay, so from this point, I have to go 3 up and 4 to the right, because they were both positive. So, positive means up and right. Oh, look at that. I wrote my little dot on the recorder. There, that's better. And then, it's hard to draw straight lines up here. Do the best you can. Try to go through them. Ta-da! So we put it in the slope-intercept form, we identified the slope, we identified the intercept, and we graphed it. Yay us! But we're not done. There's another one. 4x minus 7y equals 14. Jackson, first step on that little one. Oh, be careful. Go by the sign that's in front of it. So is this a positive 4x or a negative 4x? Yeah, let's get her out of there. It's positive. Looks like so. Emma, what next? And again, be very careful. We tend to make a lot of mistakes with negatives. Negative 4 divided by negative 7 is positive 4/7. 14 divided by negative 7 is negative 2. And now, to graph it, we're going to need to know m and b. Brandon, m is what? 4/7. And b, I guess I have to start over again. Kayla, I'll ask you again. Right, so, but you're right. Immediately our brain goes to thinking is 0, negative 2. You know, that's the point that we have to start at. So, 0, negative 2. Oh, what do I use that 4/7 again for? Nevaeh, what do I do with that 4/7? Up 4 and right 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 to the right. Beautiful. That's why slope-intercept is called a quick graphing form. Love that. It's super quick. That's what we want. We want to be able to graph them very, very quickly. Oh, that can't be it. Is that it? That's it. Well, there it is. There's day one. And yeah, that's all the notes for section 2-3. So that means you won't have to watch a video tomorrow. You can just do the assignment tomorrow for 2-3 day 2. And you'll be good to go. Oh, let me turn this off.